Hello and welcome to another exciting pre-calculus math video. This is a pretty important one. We're going to be looking at section 4.2, and the title of this is one of the most powerful mathematical artifacts out there, the unit circle. And our bullet points for this section, we will identify a unit circle, describe its relationship to the real numbers. We'll evaluate trig functions using this new unit circle. And we'll use the domain and the period to evaluate sine and cosine functions, and also use calculator to evaluate some trig functions. We've been working with the calculator for a while now, so that won't be anything new. And here we go, unit circle. Of course, you know what a circle is from geometry class, but unit here means one or single. So the unit circle is a circle of radius 1, and we are going to orient our circle's center at the center of the Cartesian plane. So the center of our circle will be the origin 0, 0. So the book says two historical perspectives of trigonometry incorporate different methods to introduce the trig functions. One such perspective is based on the unit circle. And it says here, consider the unit circle given by x squared plus y squared is equal to 1. Remember, x squared plus y squared equals r squared is the equation of a circle. And since our radius is 1, r squared will also be 1. So here is our circle. Notice here they just have the coordinate axes shown, and they point out four important points, 1, comma 0. If we move up the y-axis, that would be 0, 1. To the left, negative 1, 0. And then down at the bottom of the circle, 0, comma, negative 1. So we have a circle, again, radius 1, centered at the origin. Now it says, imagine we wrap the real number line around the circle. Positive numbers go counterclockwise, negative numbers go clockwise, and we've seen that when we did our angles. If we went clockwise, we had a negative angle. So here in the picture, this straight up here blue line is the number line, and then what we're going to do is bend that and wrap it around the circle. So now every spot on the number line becomes a point on the edge of our unit circle. And, of course, this would be 0, and we're going positive as we move around the circle counterclockwise. If we happen to be going clockwise, these would be negative values. Remember, because our angle would be negative because we're opening up in a clockwise direction. As the real number line wraps around the unit circle, each real number t corresponds to some point, an x and a y coordinate on the circle. For example, the real number 0 corresponds to this point 0 or 1, comma 0. Moreover, the unit circle has a circumference of 2 pi, so the real number 2 pi corresponds to the same point. Because if we're here at 0 and we go all the way around, that's 2 pi radians. We're back to where we started, so we're going to be at that same point. Each real number t also corresponds to the central angle theta in standard position, whose radian measure is t. Blah, blah. Oops. And then from here, let's talk about the trig functions. From the preceding discussion, the coordinates x and y are two functions of the real variable t. These coordinates are used to define the 6 trig functions of a real number t. Sine, cos, tan, secant, cosecant, and cotan. Abbreviations are there. We know what those abbreviations are. And think what we did in the section 4.4 when we did the trig functions of any angle. We saw there that the sine of theta was equal to y over r. That's supposed to be an r. And the cos of theta was x over r. Well, now, since our radius is 1, y divided by 1 is just y, x divided by 1 is just x. So here we have the sine of angle t is equal to the y coordinate. And the cos of angle t is equal to the x coordinate. This is only true if we are actually on the unit circle. And since sine divided by cos is tan, we divide y divided by x. There's our tangent value. And of course, we know if we flip over sine, we get cosecant. So that would be 1 over y. Cos flips to secant. That would be 1 over x. And cotan flips over to x over y. So let's look at a circle here, and I'm going to make this just a little bit bigger. And let's start, of course, in quadrant 1. I'm going to use black ink for my angles, and we're going to start here right on the positive x-axis. That is 0 degrees, and then our first friendly angle is 30, and our next angle is 45, and then 60, and then that takes us to the positive y-axis. That's 90. So there's the first quadrant, and let's do the second, third, and fourth. So here I am at 90. If I add my first friendly angle, 90 plus 30, this one here is going to be 120. 90 plus 45 is 135. And then 90 plus 60 is 150. And if we get to the next coordinate angle or axes, that will be 180. Now we're at 180. Let's go back to our first quadrant friendly angles. 180 plus 30 is 210. That's supposed to be a 2. 180 plus 45 is 225. 180 plus 60 is 240. And then if we count by 90s, 180, this would be 270. Okay, so we're down here on the negative y-axis, 270. Let's add our first quadrant friendlies again. 270 plus 30 is 300. 270 plus 45 is 315. 270 plus 60 is 330. And we started at 0 and we went all the way around. So now we're at ending at 360. 0 and 360 have the same values. Okay, now that we've got all the angles in degrees, just to keep this from becoming too messy, I'm going to erase the degree angles. We'll do the same thing in radians. And I'll show you a little, this is the way I worked on this when I was in high school. Because all the fractions, when the first time you're working with this, it can be confusing. So these rays right in the middle, I'm just going to highlight them in blue. These are the fourths, the 1/4. And I'll get these out of the way first. And we can't start here on the 0 or the positive x-axis. This would be 0/4 pi. So this will be 1/4 pi. Let me write it in here. 1/4 pi. We could do the next positive axis. That would be 2/4 pi, or that's going to reduce to pi over 2. And then we would have 3/4 pi. And actually, I should be writing these inside the circle. Back. So here's our pi over 4. Here's 2 pi over 4. Here is 3 pi over 4. 4 pi over 4 is just going to reduce to pi. And then we've got 5 pi over 4. 6 pi over 4 reduces to 3/2. And then we'll have 7 pi over 4. And if we go all the way around, that would be 8 pi over 4. And that reduces, of course, to 2 pi. Just like 0 and 360 we had for degree angles. Now we've got 0 radians all the way around to 2 pi. So there, again, right in the middle of each quadrant are the fourths. So we've got our 1/4, 3/4, 5/4, 7/4 for the ones that don't fall on top of the coordinate axes. Okay, now to fill in the rest of these, all the ones we did not fill in yet, I'm going to go back over. I'll use red ink this time, and we're going to go from, and actually let me keep the quarters in blue. Since these are already done, of course, we're not going to do them again. So I'm just going to leave them highlighted in blue so we don't accidentally work on one of these again. So again, we're going to go back to the positive x-axis, and now we're going to count by sixths. 1/6. So this would be here 0/6, and then we'll have 1/6 pi. And then this one would be 2/6 pi, but 2/6 is going to reduce down to 1/3. So there's 1/6, 2/6. This would be 3/6 pi, but we already have that one marked. That gets reduced down to pi over 2. Oops. Pi over 2. So it's 1/6, 2/6, 3/6. This will be 4/6 pi, and that's going to reduce down to 2/3. 2/3 pi. So that was 4/6. Here is 5/6 pi. 6/6 pi will reduce down to just 1 pi. And then we'll have 7/6 pi, 8/6 pi, 9/6, oops, get back there, 9/6 pi, 9/6. 10/6 will reduce down to 5/3. So there's 10/6, 11/6 pi, and then 12 pi over 6 will reduce down to 2 pi. So if we just don't count the blue ones, again, the quarters right in the middle, we can go around doing everything by sixths. And of course, some of these are going to reduce that I didn't on the fly. This 4 or 8 pi over 6 is going to reduce down to 4/3. The 9/6, that reduces down to 3/2. Yeah, so there they all are in radians. So we've gone all the way around in degrees. We've gone all the way around in radians. Now we can start working on the points at the edge of the circle. Because what it boils down to, this point here is an x and a y coordinate. So let me write this over here. X comma y is how we used to write points on the circle. We can also think about this now as cos comma sine. So every point on the unit circle, the x-coordinate is a cosine value, the y-coordinate is a sine value. And we can remember how to put these in. Remember back to when we were solving these on tables. So here's our sine values. 0, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. So those are our sine values or our y-coordinates. And then our cos values, our x-coordinates, are the same but in reverse. So when it comes to filling in one of these blank, this is how I've always done it. I'm going to put a set of empty parentheses for each of these. And I personally just like to start on the y-coordinates. So we're down here on the x-axis. Our y-coordinate would be the root of 0 over 2. And then our y-coordinates are going to go up as we rise up to the top of the circle. Root of 1 over 2. Root of 2 over 2. Root of 3 over 2, and then the root of 4 is 2 over 2. That just reduces down to a 1. Now, those are all sine values. All of these are sine values for the different angles. Let me put the angles in there again. Pi 6, pi 4, pi thirds. So here's my sine value of pi over 6. Pi over 3, the sine of pi over 3 is this y-coordinate. Now let's go back down doing the x's or the cos values. I'll switch to black ink. Here is root of 0 over 2. Here's root of 1 over 2. Root 2 over 2. Root of 3 over 2. And root of 4 over 2 is 2 over 2, or just 1. So there is our first quadrant. In the middle here at quarter pi, notice sine and cos are both the same. They're both root 2 over 2. Here at pi 6, the root 3 over 2 comes first, the 1/2 comes second, but that's reversed up here at pi over 3. The half comes first, the square root of 3 over 2 comes next. Now, as we go around the circle, filling those in, all of the points are going to be the same. Either a root 2 comma root 2, or a root 3 over 2 comma half, or a half comma root 3 over 2. But as we work our way around, some of those will change to negatives as we go. Okay, and let me do it like this. I'm going to have to make this just a little bit smaller. So here is pi sixth, and let's do 5 pi over 6, 7 pi over 6, and 11 pi over 6. These all have the same reference angle of pi over 6. This point again here was root 3 over 2 comma 1/2. All the rest of these will have the same point. I'll switch to red ink over here. This is going to be a root 3 over 2 comma 1/2, but here the root 3 over 2 is negative because our x values are negative in quadrant 2. Down here in quadrant 3, it's the same point, root 3 over 2 comma 1/2, but now the x is negative and the y is negative, so those are both negative values. If we work our way over here to quadrant 4, the point is still root 3 over 2 comma 1/2, but now the root 3 over 2 stays positive, and that 1/2 is now negative. So again, don't forget, these are sine values in the y-coordinate, and these are cos values in the x-coordinate. So now we've got the sine and the cos for all the pi sixth, 1/6, 5/6, 7/6, and 11/6 pi. Okay, so there's a piece of our circle. Let's go to the quarter pies now. Those are right in the middle of the quadrants. So this is our 1/4, and then we have 3/4. Notice all the numerators are odd numbers. 5/4 and 7/4 pi. Back in quadrant 1, this was root 2 over 2, comma root 2 over 2. Remember, x and y coordinates are the same here. As we work our way around, some of those will just change to negative. Here at 3/4, it's root 2 over 2, comma root 2 over 2, but now the x-coordinate is negative, the y stays positive. Down here in quad 3, same values, both are root 2 over 2, but here in quadrant 3, both of these are now negative. In quadrant 4, at 7/4 pi, it's root 2 over 2, comma root 2 over 2, but now the x is back to positive and just the y value is negative. So there are the sines and the cosines for quarter pi, 3/4 pi, 5/4 pi, and 7/4 pi. Okay, one more to go. That is the denominator 3. So here is our 1/3. Here's our 2/3. 3/3 would be the x-axis, and then we'll have 4/3. And over here will be 5/3. And if we go 6/3, that's 2 pi, and we've gone all the way around the circle. So now these points, the x-coordinate is a half, the y-coordinate is root 3 over 2. So all of these, as we work our way around, will have the same values, 1/2 root 3 over 2, 1/2 root 3 over 2, 1/2 root 3 over 2. But of course, in quadrant 2, the x-coordinate goes negative. In quadrant 3, x and y are both negative. In quadrant 4, the x is back to positive, but the y value stays negative. So there are the final angles of our unit circle. And again, these just all come right off the table, our reference angle table, and we figured out based on the quadrant that some things are going to be negative in different quadrants. Okay, so we've got a unit circle. Let's take it for a test drive. Evaluate all 6 trig functions for each real number. So here we go. And well, yeah, let's do it like this. I'm going to do sine, cos, tan. Each of these are going to be, oops, that's just pi over 6, pi over 6, pi over 6, pi over 6. So let's get sine and cos. I've just got a unit circle hiding over here. So let me make this a little bigger. So here is our angle, pi over 6. Sine value is the y-coordinate, so that sine at pi over 6 is 1/2. The cosine value is the x-coordinate, root 3 over 2. Root 3 over 2. So we've got those, and now we can use those to find the other 4. Remember, tangent is sine divided by cos. So if I do sine 1/2 divided by cos root 3 over 2, how do you divide fractions? We bring it up and flip it over. We multiply by that reciprocal. That's supposed to be a 3 under that radical. So if we multiply straight across after we reduce, we're going to get 1 over the root of 3. And if we rationalize, multiply the numerator by a root 3, denominator by the same root 3, we get that. Square root of 3 over 3. Oops, I didn't want to. There we go. Got that. Now we've got the first 3. The rest are just the reciprocals. Oops. Cotan of pi over 6, we would just flip this over before we rationalize. That's just root 3 over 1. Cos flips over to secant. So the secant at pi over 6 would be this turned upside down. 2 over root 3. And of course, we're going to have good manners. We're going to rationalize. So it's going to be 2 roots of 3 over 3. And then for sine, that's an easy one. We'll flip that over to cosecant. And we flip over the 1/2. That becomes 2 over 1, or just 2. Okay, so there's all 6 at pi over 6 angle using the new unit circle. Letter B, we're going to do the sine at 5 pi over 4, cos at 5 pi over 4, and the tan there also. Unit circle comes out, and let's look for 5 pi over 4. Here it is. We're down here in quad 3. 5 pi over 4. So our sine value is negative root 2 over 2. Our cos value is the x-coordinate, also a negative root 2 over 2. And then tangent is sine divided by cos. So here's sine divided by cosine. So we're dividing something by itself, and that's going to turn into a positive 1. So there's the first 3. We get those right off the unit circle. Let's flip those over. You know, if we flip over sine, we're going to get cosecant of 5 pi over 4. So it's going to be negative 2 over the root of 2. And if we rationalize that, we'll get 2 roots of 2 over 2. Let me write it up here. 2 roots of 2 over 2, and don't forget that's still negative, and the 2's will cancel. So just a negative root of 2. Negative root 2. Cos flips to secant, and it's going to be the same thing. We're flipping over the exact same thing we flipped up here, negative root of 2. And cotan, that's the easiest one of the bunch, because if we flip over 1 over 1, we just get 1 over 1. All right, one more to go here. Now it's a negative angle, sine of negative third pi, cos of negative third pi. And let's just do the first 3. I think you see what's going on with the reciprocals. So now remember, a negative angle, we are going clockwise. So let's get the unit circle. We can see it here, quadrants 1 and 4. If we go positive 1/3, we've gone that far. So negative 1/3, we're going to go in the opposite direction. Notice when we went this way, we stopped on the first one with a denominator 3. Same thing when we go clockwise for a negative angle, we stop at our first one with a denominator 3. So negative 1/3 pi is the same as 5 pi over 3. Notice here is our point. I'm going to write it up here in the corner. So our point is 1/2 comma negative root 3 over 2. So the sine value there is just the y-coordinate, negative root 3 over 2. The cosine there is just the x-coordinate, positive 1/2. Tangent is sine divided by cos. Ooh, so I'm just going to sneak up here and do this. Sine divided by cos. So I'm going to bring this denominator up, flip and multiply. So now it's times 2 over 1. And the 2's cancel. So we're just left with a negative root of 3. And there's sine, cos, and tan of a negative 1/3 pi. Right. What's next? Domain and period. The domain of sine and cos is the set of all real numbers. Remember, the numbers that we are allowed to put in are the domain, all real numbers. To determine the range, consider the unit circles shown back in the figure 418. Let me do it like this. So remember, and all of these are equal to 1. All the radiuses are 1. So we know that sine is equal to the y-coordinate and cos is equal to the x-coordinate. Moreover, the point x comma y is just a point on the circle. So we now know that the y values will only vary between 1 and negative 1. So here's our y values from 1 and negative 1. So that means our sine values are stuck between 1 and negative 1. And the cosine values pair up with the x-coordinates, so that would be these values. So cos also stays between 1 and negative 1. And remember, the real number line has been wrapped around the circle. So no matter what number you put into sine, the only outputs are between negative 1 and 1. Cos. T could be any number, but your outputs, no matter what you put into cos, the only thing coming out is a number between negative and positive 1. And if we get a value and add 2 pi to it, we get right back to where we started. That's just another revolution around the circle. So it says the values of sine of t plus 2 pi and cos of t plus 2 pi are exactly the same as sine of t and cos of t, because adding that 2 pi just went around the circle again. We've landed back at the same point. Repeated revolutions yield similar results. So any angle sine of t plus 2 pi times some integer n is the same as the sine of t, and the cos of t plus 2 pi times some integer n is also the same as cos of t. Functions that behave in this repetitive or cyclic manner are called periodic functions. They're used to model recurring phenomena in the real world. So here's our definition, math book definition of a periodic function. Function f is periodic when there exists a positive real number c, such that if we add it to the original f of something, they're exactly the same. F of t is the same as f of t plus some number c. And again, in our case, that's a 2 pi because that takes us one more lap around the circle. Back in section 1.5, we did talk even and odd functions about their symmetry. Trig functions are also even and odd. So here we've got cos of negative angle t is the same thing as cos of t. All the rest of them, it's sort of like this negative escapes. The sine of negative t is the same as the negative sine of t. Also for its reciprocal, and tangent works the same way. Tangent of negative t is the same as negative of tan t. Like if you just went to your unit circle and looked at the tan of negative 30 degrees, that is the same as the negative of tan of 30. If that makes more sense with numbers instead of t's in there. So let's try these out. Evaluate sine and cosine. And let me just grab my unit circle. Okay, this first one, sine of 13 pi over 6. I like to turn it into a mixed number first. That is the same thing as the sine of 6 goes into 13 twice with 1 left over, so that will be 1/6 pi. So that's 2 and 1/6 pi. That is exactly the same as, remember, if we go around the circle, that's 2 pi. So we can sort of just cross that out. So that's exactly the same thing as the sine of pi over 6. So the sine of 13 pi over 6 is the exact same thing as the sine of pi over 6. And if I bring out my unit circle, here's pi over 6 radians. The sine value is the x-coordinate. So that's equal to 1/2, equal to 1/2. So again, the sine of 13 pi over 6 is equal to 1/2, just as the sine of pi over 6 is equal to 1/2, because those are periodic functions. This one here, cos, and now careful, we're going negative. This is the cos of negative, well, 2 goes into 7 3 times without going over, leaving another 1/2 pi, 3.5 pi. And remember, this is in a negative direction. So let's see what this is the same as. I'll pull my circle up here a little bit more. Negative 3.5. Here is negative 1 pi, negative 2 pi, negative 3 pi, and 1/2 will take us one more coordinate axis to that positive y-axis. And notice we did stop there on positive 1/2 pi. Oops. So positive 1/2 pi. So the cos of negative 7 pi over 2 is exactly the same as the cos of positive pi over 2. And remember, at that point, our cosine value is the x-coordinate. Up there, the x-coordinate is 0. So these are both equal to 0. All right, what is next? I think this is our last example. Yeah. So here, this is calculator stuff. So the sine of 2/3 pi, we got to figure out what mode you're in, the calculator keystrokes, and what the display is going to look like. Dead giveaway here, because of the pi, it is in rad mode. And depending on the calculator, a TI-30, I would do 2 times pi equals divided by 3 equals, and then I would hit the sine key, sine, making sure I'm in rad mode, and my display gives me 0.8660254. A lot of times you see these rounded to 4 spots, so just 0.866 would work just fine. Now, letter B, I do not see a pi, but I also do not see a degree symbol. So this one is also in rad mode. And for the calculator keystrokes, I would do the 1.5. And then since we don't have a cotan key, I would hit the tan key to take the tan of that, and then flip it over with the 1 over x key, or x to the negative 1. Calculator display will give you 0.0709148. If we round that to the 4th spot, it would just be 0709. And on the TI-89s, you'd hit the trig function first, like that first, you'd do sine, it would give you the left parenthesis, and then you'd type in 2 times pi, divide 3, and then hit enter on the TI-89. So a little calculator work there. And now it's time for some of you to practice on your own. Let's see here. Finding all 6 of these is a little much. Let's get rid of this one and this one. So here we got a positive angle. That's going to land you on a coordinate axis. This is a negative angle. That'll stop you in a different. I'm not going to even tell you what quadrant that stops in. So find sine, cos, and let's just do not all 6. Let's just do sine, cos, and tan. Let's just do 3 of those. Sine, cos, and tan, because if we flip them over, we know what we're doing there. This one, figure out sine and cos. These can, because of the periodic nature, you're going to do a few laps, but you're going to stop somewhere friendly. And then the last 2 are calculators. So pause the video and try these problems out, and then start it back up and see if you got them right. So first up, sine, cos, and tan at pi over 2. Pi over 2. And I should have brought along my unit circle. I got it right here. I'll just bring it along. There we are. And I'll leave it here so we can see the angle that we're dealing with first. Pi over 2 is right here. So here is our sine value. Sine value is 1. 1. Why is my pen not working? Okay, that is 1, and my pen is still, there we go, 1. Our cosine value is the x-coordinate. That's going to be a 0, 0. And then tangent is sine divided by cos. Now, I've got sine as 1. Come on, pen. Sine is 1, cos is 0. Dividing into 0 is fine. Dividing by 0 is a no-no. So that is undefined. The tangent at pi over 2, if my pen works, is undefined. Undefined at pi over 2. Okay, and my pen is still glitching out here. So negative 3 pi over 4, I'm not going to be able to write those angles in. So in your notes, this should be, I'm going to try my mouse here. This is probably going to be terrible. But that is the sine of negative 3 pi over 4, the cos of negative 3 pi over 4, the tan of negative 3 pi over 4. So I'm going to bring my unit circle up here so we can see this a little better like this. Here we go. So remember, negative is going clockwise. Let's see if my pen is going to be a little more cooperative. So if we're right here and we go this far, that's negative a half pi, and then this would be negative 1 pi. So we've gone too far. We want to go negative 3/4. So here again is negative a half. Negative 3/4 is going to take us right here. So here are our sine and cosine value. Sine and cos are both the same. They're both negative root 2 over 2. Let me get this out of here. So sine and cos, oh, there's my pen's a little better now, negative root 2 over 2. Tangent is sine divided by cos, so if we're dividing something by its exact same self, that will divide out to be a 1. And there we go, sine, cos, and tan of negative 3/4 pi. Next problem, aha, here we go. Cos of 9 pi over 2. Well, let's turn that into a mixed number. 2 goes into 9 4 times, plus there'll be 1 left over, so that's 4.5 pi. Now remember, each lap around is 2 pi, so if we do 2 pi, we can cross off 2 of those. If we do another 2 pi, that takes us to 4. So the cos of 4.5 pi is exactly the same as the cos of half pi. And on my unit circle, half pi is up here at the top. The cosine value is the x-coordinate. So these are both equal to 0. The cos of half pi is 0. The cos of 4.5 pi is also 0 because of the periodic nature of the functions. Letter B, the sine of negative 7/3 pi. Well, that's the same as the sine of negative 7, or 3 divides into 7 twice without going over, but there is a remainder of 1, so that's negative 2 1/3 pi. And again, because a trip around the circle is 2 pi radians, we can sort of get rid of this too because of the periodic nature of the function. So let me write it like this. The sine of negative 7/3 pi is exactly the same as the sine of negative 1/3 pi. So if I bring my unit circle up here, here we are at 0. If we go 1/3 in the negative direction, that takes us to this 5/3 pi. And our sine value there, let me move this up a little bit. Our sine value is negative root 3 over 2. Negative root 3 over 2. So the sine of negative 1/3 pi has that value, as does the sine of negative 7/3 pi, has the same value. And I think that was it for that one. Yeah. The last two here are calculator problems. The first one's not bad. 5 times pi equals, divide by 7. You hit the sine key, and you get, let's round these to 4, approximately 0.8660. Now, cosecant of 2.0. There is no degree symbol, so this is not degrees, it's radians. There's no pi, but it's still in rads. So I would hit 2, and since cosecant's not on the calculator, I would hit the sine key, so the sine of 2 rads, and then I would flip it with the 1 over x key. If everything went according to plan, 0.0709. And there's our answer. I believe that is the end of the video. Look for the assignment on WebAssign. Next time we're together in class, we'll do some odd problems. I will see you then.